Hi, good morning all. Once again, come back to our new session. Today I am going to teach you about in mechanical engineering bits, and this session is completely about how to solve competitive mechanical exam bits. Today I will teach you some bits. Please follow, and if you like, please subscribe for getting such knowledge and subject. Okay, now starts. The first bit is the second movement of a circular area about the diameter is given by, where d is the diameter. See, here he is asking about the second movement of a circle. The options are given: a pi d power 4 by 4, b pi d power 4 by 16, c pi d power 4 by 32, d pi d power 4 by 64. So what could be the answer? Here we have to understand that what is movement, what is second movement, and what is movement of area, and what is mass movement. See, mass movement or movement is mass into perpendicular distance is called the mass movement, where area into perpendicular distance about which point or which location you want to calculate the moment, it is called the mass into or area into the perpendicular distance from that point. So here he is asking the circular area second movement. So what is second movement? If you calculate the movement twice, that means area into perpendicular distance again multiplied by perpendicular distance, that is called second movement. That means you are calculating two times the movement. See, in this case, if you are taking the circular movement, so second movement he is asking. Here you have to understand from the perpendicular axis theorem. We already know that polar moment of inertia, that is IP, is equal to pi d power 4 by 32. That is also called IZZ, that means the axis of the circle. You already know from perpendicular axis theorem Ixx plus Iyy is equal to IZZ, where IZZ is nothing but IP. Here it is a symmetrical section, circular is a symmetrical section, so Ixx is equal to Iyy. So you can write 2Ixx is equal to Izz or IP. So therefore Ixx is equal to IP by 2. So we want about the diameter, so we have the Ixx is the about the diameter. So answer is pi d power 4 by 64. So answer is D, pi d power 4 by 64. So the second moment of a circular is about diameter pi d power 4 by 64. Now the second question, a concentrated load of P acting on a simply supported beam of span L at a distance L by 3 from the left support. The bending moment at the point of application of the load is given by. See, here a simply supported beam is a beam which is simply supported at both ends. It is having two supports. The first support is left side and the other support is right hand, and first support is the left hand. So it is having a span of L, that means the length of the beam is L. Here a load is applied at a distance of L by 3 from our left hand. So what is the bending moment? So how we calculate the bending moment? Bending moment is nothing more but the force into perpendicular distance. So for this the options are given: A PL by 3, B 2 PL by 3, C PL by 9, and D 2 PL by 9. See, here you have to first calculate the reaction forces and you can calculate the moment, because at the left end you are having a concentrated load. Concentrated load means that is a point load at a distance of L by 3 from the left end. So here we are calculating, first we take the moment about the left end A. So the right hand is the reaction is R, means the reaction RB into length of the beam L is equal to, what is the, that means that is the anti-clockwise direction, that must be equal to the clockwise direction of movements. So you are having only one single load at a distance of L by 3 from the right hand, so that must be equal to clockwise movement P into L by 3. So therefore RB is equal to P by 3. So you got RB. So how we can calculate RA? How we calculate RA? So the total load is only P, that is single load is acting at the top of the beam. So the total load will be shared by the both reaction forces. RA plus RB must be equal to P. So therefore a reaction force RB is equal to P by 3, we already calculated, which will be submitted in this one. So RA plus P by 3 is equal to P, RA is equal to P minus P by 3, so RA is equal to 2P by 3. So from this, now what is the bending moment at point P? So how we calculate the bending moment? You can calculate from the right hand or left hand. So at point P, if you calculating about the point P, so from the left hand if you calculate, there is only one reaction force you can find from the left side, that is equal to 2P by 3 at a distance of L by 3. So the bending moment will be force into distance, that means RB into L by 3, that is equal to 2P by 3 into L by 3. That means left hand is RA, that is 2P by 3 into L by 3, that is equal to 2PL by 9. So answer is D, 2PL by 9. Next the question is, two beams, one having square cross section and another circular cross section, are subject to the same amount of bending moment. If the cross section area as well as the material of the beams are the same, then options are given as A, maximum bending stress developed in both the beams is the same, B, the circular beam experiences more bending stress than the square one, C, the square beam experiences more bending stress than the circular one, D, as the material is same, both beams will experience same deformation. So here everything is even including the material also same, but only thing is even the cross sections also are the same, but only thing here is the geometry of the section is, one is the circular cross section geometry of the beam and the other one is square cross section. So he want to know which is developing the more bending stress. So in this case again we have to bending stress formula. We know that standard equation for bending equation is M by I is equal to F by Y is equal to E by R. This you have to remember. So we have to substitute and we have to identify which is getting more stressed. So in this case we have to know M by I is equal to F by Y is equal to E by R. In this case Y, we will take that M by I is equal to, here F plus E is taken sigma C, the notation is just in stress notation, sigma C or F whatever. So sigma C is equal to My by I. Okay, so here Y is equal to the maximum bending stress area, that is in case of circular you have to take T by 2 and in case of square section you have to take A by 2 by substituting. And you know what is I is the, what is I, moment of inertia or second momentum. So one is circle and the other one is the square, that pi by 4 d power 4 for the pi d power 4 by 64 for the circle, and a power 4 by 12 is the even square. So here we are substituting m into d by 2 pi d to power 4 by 64, that is equal to 32 m by pi d cube, and the other case square section, what is the bending stress if you calculate 6m by a cube. So we want to know which is getting more stressed. You can just divide one with the other. Okay, 32 a cube by 6 pi d cube. So here we need a relation between, because one is in a cube, another one is the d cube. So he has given one condition, that is both the areas are same. From that you can calculate the pi by d power square is equal to a square. You know the area pi d square by 4, that must be equal to a square. From that logic, d square can be replaced by a square 4a square by pi. So you substituting a will cancel, and what you get is the value is, by using your calculator, that is more than 1. That means circular cross section will experience more bending stress compared to square cross section. Okay, thanking you for today, and